Welcome viewers to the SD online classes. This is class 10 MBSc chapter 3 name physics. Name of the chapter is electricity. In your page number 72 of your MBSc textbook, you can see the topic is resistance. What is resistance? Resistance is the property of a conductor to resist, means oppose the flow of electric current through it. When charge is flowing, the electron inside it is flowing, that time how much it can oppose it is its resistance. If it can oppose more, less current will flow through it. So that means its resistance is high. Okay. So what is R? Symbolically in the circuit we'll show it like this. Okay. The ends will be like this connected. Its SI unit is ohm, already known to us. Now, so this is the obstruction offered by a conductor in the path of moving electron or charge. And already we know that R is equal to V by I is the formula that we can use for our purposes. Okay, so this was the whole thing about resistance. Now there is another thing, what is rheostat. Rheostat is, by the name itself you can understand, variable resistance. If you have a resistance where you can change the value of the resistance, it will be called rheostat. Okay, so this is usually used in your experiments. So this will be its symbol, resistance, and this line indicates that it can change. Or this is also written another way, they also write like this and this way. This implies that it can be here, it can be here, it can go move here and there. So you can change that. Suppose it is resistance can be only one way, fixed value, 2 ohm, finish. If it is 5 ohm, finish. But here you can make 5 ohm, you can make 2 ohms, you can make 10, 5, 3, like that. You can change here. So this is called rheostat. That is the difference. Okay. So the unit of resistance we already know, omega. So we'll do one more thing there. What is 1 ohm? You remember 1 volt also was done, 1 ampere was also done. Similarly, we'll do 1 ohm. How it to be done? R equal to V by I. Can you guess what is this? It is the question when R will be 1. R will be 1 when V is equal to 1, current will be 1, that time R will become 1 ohm. Let us write in words. What is that? 1 ohm. 1 ohm is resistance of a conductor is said to be 1 ohm when 1 volt of potential difference produces 1 ampere of current. If that happens, you can say that conductor is having 1 ohm resistance. Let us write in words. So this is the definition. You look at here. The resistance of a conductor is said to be 1 ohm. This will be 1 ohm when current of 1 ampere, current become 1 ampere, flows through a conductor on applying, if you first do this, then this will happen. Okay, on applying a potential difference of 1 volt. Important is this 1 volt, this 1 ampere will make 1 ohm. Okay, mathematically it is very easy. When this is 1, this is 1, this will be 1, and writing in words that one. Okay, understanding and writing. So this is about resistance. Next topic. Okay, now this topic is conductors, resistors, insulator. Of course, one more is there in between. We'll understand what is that also. Let us see. You know that resistance is different for different material. If it is gold, it will be different. If it is iron, it will be different. If it is a sulfur or hydrogen or whatever new element, it will be different. New compound, it will be different. Okay, wood will be different. Rubber will be different. So depending on their way of resisting the current, that means depending on their value of resistance, materials are categorized, separated. Some are having good, some are not good. So there are 3 types. Conductors. What are conductors? Let us see. So let us understand. This type of substance, conductors are what? They are which offer very low resistance. Okay, they will not oppose the current. Current flow through them easily, and less obstruction, less disturbance in the path of flowing electrons. So they are having more current to pass through them and less heat. In the conductor, almost no heat is generated when the current is flowing through them. Okay, and similarly the next will be your resistors. Okay, resistor is slightly less than this conductor. Again go on like that. Now look at resistors. This substance, the substance which offer high resistance to the electric current compared to conductors. Okay, and there are more obstructions in the path of the flowing current. They don't easily allow the current to pass through them, and less current will be, as a result, less current will flow from them. Even if you pass more current, less current will flow from them, and more will be heat generated. The current is used up more in heating the material, this resistor. Here the current is used all in going from one place to other. Here some part of the heat, or most of the part of the current is used in heating up. So similarly, there is one more, which is poor conductor. Actually this is, we don't write usually poor conductor also there. Okay, this category, third category, poor conductor. Poor conductor, the name itself it suggests, they offer a resistance higher than resistors, and they allow negligible current, almost no current flows through them. Okay, the last one remains the worst case. This case, the last one, this substance offer an infinitely high, that means a resistance which is so high that no current can flow. Okay, it is like broken circuit. They do not allow, something like your wood, something like your what you call rubber, all this, they do not allow current to pass through them at all. No current will pass through, even if you try to connect with some battery or any other current source, potential source, no current will flow through them. So this is the way. Mainly you have to remember conductor, resistor, insulator. Conductors are generally metals, resistors are not, non-metals mainly, insulators are also mainly non-metals. Okay, they are not conducting. So this is all about your three types of conducting materials. Okay, this topic is factors on which the resistance of a conductor depending on how many things the resistance depends. This is the detail inside of the resistance we try to understand. Okay, it is simple. Resistance depends on how? Number one, R is directly proportional to L, length of a conductor. If the length is longer, resistance will be more. For anything, that is true. Number two, the R will also depend on the area of cross section. Area of cross section, suppose this is the wire, this is the wire, this is called area of cross section. Okay, understand? Suppose this is the wire, I am magnifying the wire. Okay, this is the length, this is the length, this is the area of cross section, the circular area. Okay, if that area is more, that means if this is more, suppose this type, so you can see this type, if that is, this area is more, of course this is all filled up. Okay, if that is more, what will happen? The area will be if there is more, resistance will be less. How it is? Less the road will be bigger for the flow of electron. Of course there are electrons inside, isn't it? If it is length more, that means it will take more time to reach, isn't it? That's why resistance is more. But if that is just big here, what will happen? The electrons will find it easy to go from there because the area is bigger here. That is the concept. These two things. One more, how to combine them. So R is directly proportional to L by A. Now one more thing on which it will depend is that R is equal to rho L by A. This is also called constant of proportionality, where rho is the constant of proportionality. What is this? Resistivity. Remember, this is not resistance. Okay, resistivity of the material, whatever it is, conductor or insulator, whatever, that is resistivity. Resistivity is what? That means what material it is. It will depend on the length, it will depend on the area, but it will also depend on the material. I have already told you that, isn't it? Resistivity will decide if it is, whether it is a gold, it is a silver, it is a iron, it is a copper, what it is, it will be decided by this. So three things. Now everything is there. Resistance will be decided by the length, resistance will be decided by the area of cross section, resistance will be decided by the resistivity of the material. So let us try to understand what is resistivity alone. This is the formula important. If I write rho here and transfer all this here, it will give me A by L like this. If I write in terms of resistivity, the resistance, it will be reverse. Okay, so that means that is the this is called your resistivity. Another name of resistivity is specific resistance. Okay, we can write the definition of specific resistance also. These two are same thing. Okay, these two are same thing. Specific resistivity and resistivity. Specific resistance and resistivity. Resistance is different. Okay, these two are same. Now, how to define them? It is very easy. When you make this and this one, they will be equal. That we are going to use. Okay, how? If L equal to 1 meter, A equal to 1 meter square. Why meter square? Area's unit is meter square. Then what will happen? Then rho will be equal to R. Can you understand? Put 1, this will be equal to same. Rho equal to that we will write. Just like 1 volt, just like 1 ampere, just like 1 ohm, we are defining this resistivity here. How? The resistivity will be equal to the resistance when 1 meter long wire or conductor has 1 meter square of area. Okay, that is so easy to define. So let us write that. So this is the way of writing it. Okay, resistivity of a substance is the resistance itself. But when the wire is 1 meter long and the area is 1 meter square, at that time resistivity is the resistance. Okay, resistivity is the resistance, means they are equal. Okay, resistivity of the substance is the resistance. Don't say they are same. Okay, they are same numerically only when this is 1 meter, this is 1 meter. So that is how we define it. Simple. Let's move on. Now look at here, the SI unit of resistivity is ohm meter. How it is? Because the formula is R A by L. Remember, this was the formula. Why this is so? Because R was equal to rho L by A. We already did this. Okay, because of this, this is 2. Now let us write their unit. Ohm, area is meter square, length is meter. Let's cancel them. Ohm, meter. Okay, the unit of resistivity is SI unit of rho is this much, ohm meter. Fine. So one important thing you have to know is that R is depending on what? Depending on L, depends on A, and it also depends on rho. These three things can decide R, but rho is independent of length and A, independent of L and A. Why? This is an inbuilt property. You cannot change. Okay, if it is gold, it has to be gold. Same resistivity. But resistance can change. If the gold is very long, different resistance. If that gold is very short, different. If its area is big, less. If the area is less, it will be more. So like that the resistance will change. But the resistivity for the same material cannot change because of these things. These are the important things. Okay, resistivity is the characteristic property of the material. Therefore it varies over very less factor. Okay, you cannot change it. And now different things will have different resistivity. That is given in your page number 75. You can see some are conductors. Page number 75 it is given. Conductors are there. Some are alloys are there. It is given like that. I am giving in short. And some are there insulators. You can see all have different resistivity. I am writing some like silver, copper, aluminium. Silver has 1.60 into 10 to power minus 8 ohm meter, very less. Can you see? 1.62 into 10 to power minus 8 ohm meter, almost similar. Aluminium is 2.63 into 10 to power minus 8. Look at them, they are very less, 10 to power minus. Now alloys are also there like Constantan, made up of copper and nickel alloys. These have 49 into 10 to power minus 6, slightly more than this, but still very less. Okay, now you see at the insulators, popular insulators which do not conduct electricity are glass, 10 to power 10 to 10 to power 14. See, these are all plus 0, very very high. Okay, rubber, hard rubber. What is the resistivity? This is ohm meter. Hard rubber is 10 to power 13 to 10 to power 16. No way current can pass through them. Okay, so these are the things used in electrical circuits. These are only used for insulators where we don't want the current to pass. Other popular are diamond also. Diamond is very poor conductor. It is insulator. Okay, paper also very poor conductor, dry paper. So these are the way you can understand what is resistivity and how they are written there. Okay. Okay, small topic here I will write. This is important. You will write after this. Okay. Sigma. This is called conductivity. I am not using one more paper for this. Resistivity's inverse is conductivity. Conductivity is 1 by rho. Remember, write this. And its SI unit will be just opposite of sigma. This symbol is sigma. Sigma stands for conductivity. Conductivity is 1 by resistivity, opposite of inverse of resistivity. SI unit of sigma is ohm inverse, meter inverse. Because the resistivity unit is ohm meter, so SI unit of conductivity will be ohm inverse, meter inverse. Okay, so that is the opposite of your resistivity, right? You can go through your page number 75 and 76 detail. You can read there how the resistivities are different for different type of materials. Low resistivity, high resistivity, all is given there. Okay, this all in this class. Thank you.